Hi everyone. Now I will going to present the proposition 6 to 10 of Euclid's book 1. So now let's first discuss the proposition 6 of Euclid's book 1. So if a triangle has two angles unequal or I'm sorry, if a triangle has two angles equal to one another, then the sides subtending the equal angles will also be equal to another one. So as you can see that we have an angle ABC and angle ACB, and it is given that our angle ABC and angle ACB is equal to each other. So now we will going to prove, or what the proposition trying to prove, that side AB is equal to side AC. So there is saying in this proposition that line AB is equal to line AC, and if not, of course they are not equal. So let's have an assumption. So bakit ba meron tayong assumption? Because we will going to prove this proposition by contradiction. So yun. So yung assumption natin is yung line AB and line AC natin is not equal. So let's say that the line AB is greater than AC and line AC is greater than AB, or vice versa. So let's use that the line AB is greater than line AC. So according to proposition 3, so given two unequal straight lines, a segment can be cut off from the greater line that is equal to the lesser line. So given kanina sa assumption natin na yung line AB is greater than AC, so ika-cut off natin yung line AB natin. So ayun na yung magiging point din natin. And yung line CD ay, according to postulate 1, to draw a straight line from point to any point. So since kinat natin yung line AB natin, nagkaroon tayo ng point, which is yung point D natin. And given na meron tayong point rin, opposite to our point D, or opposite to our line AB, is yung point C. And according to postulate 1, to draw a straight line from point to any point. So i-connect natin yung point D sa point C natin. So that's why we have point D and C, or that's why we have line D and C. So let's say that, or let's have another triangle, the triangle DBC. So by the contradiction nga, the triangle EDC and triangle ABC is equal. So according by proposition 4, or yung SAS natin, it states that if two triangles have two sides equal, two sides respectively, and their included angles are equal, then the triangles are congruent, their bases are equal, areas are equal, and remaining angles are equal. And let's say that our triangle DVC is equal to triangle ABC. So according yan sa ating proposition 4. And according to common notion number 5, di ba, ang triangle ABC natin is, and yung triangle DBC natin, yung part ng ating triangle ABC is yung triangle DBC. Sinasabi kanina sa proposition 4 or yung naunang statement natin that triangle DBC is equal to ABC, which is the triangle DBC is only a part of the whole triangle. So according to common notion number 5, the whole is greater than the part, meaning to say that the triangle DVC is not equal to our triangle ABC. So therefore, if they are not equal, then our triangle ABC or the line AB and line AC natin kanina is equal. So let's proceed to the proving of our proposition 7. So according to proposition 7, on the same straight line, two other straight lines equal respectively to two given straight lines which cannot be constructed at a different point on the same side of the straight line, but having the same ends as the given straight lines. So to prove this, we will use proof by contradiction. So in the same straight line AB, so that's our base. Suppose two different points C and D. We have C and D. So it is given that our line AC is equal to our line AD. It's connected to our 2 points, point C and D, right? So, and also our line BC is equal to our line BD. So, assume or suppose both points C and D exist on the same side of AB. Same side of AB. So, as you can see there. So, our point CD, we will connect it using our postulate 1, which is, so we can connect as to draw a straight line from point to end point. So yun nga, we have 2 points, so we can connect it to make it a straight line. So now we have our AC is equal to our line AD, and line BC is equal to line BD, and CD. Yes, we have this common side, our line CD. So we will use proposition 4 here. We will use the proposition 4 to prove that the side and the included angle are the two sides of our two triangle, and their included angle is equal. So we will also use proposition side to make an isosceles triangle. So we have isosceles triangle, right? So we have two triangle. We have one isosceles triangle here. So according to proposition 5, in an isosceles triangle, the angles at the base are equal, and if the equals sides are produced, the angles under the base are also equal. So our triangle ECD is isosceles, right? And our triangle BCD is also isosceles, and as you can see, or as we will draw an angle here, the base angle of our isosceles triangle ACD and CDB. So we will have our triangle, our angle here. So, oh, so since AB are on a straight line, angles around line CD must behave consistently by using postulate 2 and the basic angle facts. So now observe at point C, angles ACD and BCD. At point D, angles CDA and CDV. So by common notion 2, the things equal to the same things are equal to, I mean the common notion number 4, the things equal to the same thing are equal to each other. So by contradiction, we can just or or our contradiction shows that assumption or our assumption is false, for our both triangles must mirror each other perfectly. This forces that C and D must be coincide with each other. But in some instances, or so you can see, hindi nag-meet or hindi nag-coincide yung ating C and D. Therefore, our assumption is false. So, therefore, there cannot be or therefore we cannot have two different points C and D on the same side of AB, such that AC is equal to AD and BC is equals to BD. Only one such point can exist. So let's proceed to proposition 8. So according to proposition 8, if two triangle has the same side equal and the same observed bases are also equal, therefore the angle inside the triangle is also equal. So what proposition 8 is trying to prove, or what we're trying to prove here, that the angle inside our two triangle is also equal. So given there given that the side EB is equal to side DE, AC is equal to line DF, and line BC is equal to line AF. So we know that alam natin na yung line EB is equal to line DE, and yung angle ABC natin is equal rin sa angle DFE, and our line AC and line DF is also equal. So their basis is equal. So between our line AB and line AC, we have the angle AVC, right? And the same with our triangle DEF. So according to proposition 4, that if two triangles have two sides equal, so yun nga yung ating side EB and side DE and side EC and side DF natin is equal to the two sides of other triangle, and the included angles are equal. So sabi rin na ang ating angle ABC and angle DFE is TEF is also equal. So then the triangles are congruent. And let's proceed to the contradiction, or the proof by contradiction. And if happens that our line EC and line DF don't lie at the same point, or don't meet at the same point. So given that we have our line AVC, and if we put it together, line AVC and line BC, so since sinabi kanina na yung line AB natin and line DE is equal, and yung bases natin is equal, which is yung ating line BC and line EF. So if it happens that our line AB and line DE don't meet at the same point, like like to these two triangle, which is the triangle DEF and line GEF. So ang sabi kasi sa proposition 7, if the two sets of equal sides built by the same base from the same side, they cannot meet at the same time. So since they didn't meet at the same time or at the same point, then automatically the, the angle inside them is not equal. So that's the proof of by the contradiction, but still we cannot prove that our included angle, or the angle inside our two triangle, is equal. So to prove that, we will use the proposition or the common notion number 4, which the things that coincides with each other is equal to each other. So since sinabi natin kanina na yung ating triangle ABC is equal to triangle EDF, or yung dalawang triangle, since yung dalawang triangle natin coincides with each other, meaning to say that their sides is equal and their angle must be equal na din. So that's all for our proposition 8. So now let's proceed to the proposition 9. So, in proposition 9, to cut a given rectilinear angle in half, let BEC be the given rectilinear angle. So it is required to cut it in half. So by proposition 3, let's cut our line AB to half line AD. So since kinat natin yung line AB, and kaya nagkaroon tayo ng line AD, we will use the line AD to cut our line AC. Since line AC is greater than line AD, we can cut the line AC into part again. So that's why we will have our line AE. So since we have line AD and line AE na, then we will have our point D and point E. By postulate 1, we can connect these 2 points to create a straight line. So yan, to create a straight line. So since nakagawa na tayo ng straight line, we can make an equilateral triangle according to proposition 1. We can make an equilateral triangle by using a straight line. So since nakagawa na tayo ng equilateral triangle, we can connect our line A to line F by postulate 1. And and since binisect natin yung ating, so we know that our line AF bisected our triangle ADE and triangle DFE. So we know that line AD is equal to line AE and our line DE is an equal basis of our two triangle line triangle DEF and triangle ADE. So we know that they are equal, and we know that our triangle DFE is an equilateral triangle. So expect na natin na yung sides niya is equal. So since para silang equal since yung dalawang triangle natin is equal, with proposition 8, if the three sides of our triangle is equal, or yung triangle ADE natin is equal to triangle DEF, so our angle inside the triangle is also equal. So now let's proceed to our last proposition that I will present, to proposition 10. So to cut a given finite straight line in a half, let AB be the given finite straight line, so it is required to cut the finite straight line AV in half. So supposed to be we have our line AB, and that line AB is our finite straight line. So according to proposition 1, we can make an equilateral triangle from our finite straight line. So as you can see here, that's why we have our equilateral triangle here. So and by triangle ECT, I mean we will bisect a line, or we will bisect this triangle using the proposition 9, and because of this will have our point D here to cut our triangle. So because we bisect triangle CT to we bisect line CB to our triangle CAB or ACB, whatever the triangle it is. So since we cut it, the angle inside this triangle also cut into 6 angles, since they have three angles before, now they have 6 angles na. So the proposition 4, our triangle BCD and CAD must be equal. So since the two sides of our triangle is equal, line CB is equal to our line CA, or we can just simply use our line CD for the both triangles. So since the line CD is both line of our triangle ACD and the triangle CDB, and line AD and line DB serves as the base of our two triangles. So since the two sides of our triangle is equal to the two sides of another triangle, therefore the included angle of this both triangle is also equal to each other. Therefore, our triangle ACD and triangle BCD is equal to each other, and AD AD is equal to our line DB. So that's all for the proposition 6 to 10. Thank you for listening.